3.1. Using figure 10, give the four-figure grid reference for the headland with the cliffs. Shade one of the circles in only. So the answer is 4240. So let's just double check. We go across first, 4240, which is that part there, which represents that grid square, which is obviously the headland. Questions 3.2. Using figure 10, which of the following coastal features is not shown in grid square 4339? So 4339 is this one here. So if I can zoom in a little bit, this bit here. So the answer is there is everything apart from a coastal spit. So we've got the beach, but there is no spit there. Question 3.3. Using the figure 10 again, what is the length and average width of Woolacombe Beach between X and Y? So if we zoom out, so you measure the distance from X to Y in terms of the beach length and the average width. So what we need to do is simply measure that and then reference it down the bottom. How many kilometers is it? And it should work out that the length is around about 3.3 kilometers, and it is 0.4 kilometers wide. 3.4. Using figure 10, can you suggest one reason why this coastline has suitable conditions for the formation of sand dunes? Because remember, not every beach will have sand dunes at the back of them. So what conditions are needed? Well, it's really obvious, to be honest. You need sand. And, you know, looking at this OS map, you've got a very long, wide, sandy beach. So simply by saying there are sandy beaches, and therefore the sand might be picked up and moved or transported by a strong onshore wind to the back of the beach, and that could be how the sand dunes form. Next question, you've got a photograph and you've got a feature labelled Z, and for 1 mark you've just got to identify what that landform is called. So here are your cliffs, and here is what used to be the bottom of the cliffs before they collapsed in. So this feature is called a wave cut platform. 3.6. Explain how a coastline of headlands and bays forms and changes over time. So this idea of changes over time seems to be very common in the exams. So loads of keywords here. So first of all, you've got a couple of different types of coastline. The one where you've got loads of different types of rock touching the water here is called a discordant coastline. Discordant. So I would say at a discordant coastline, you've got hard rock and soft rock. Now, the key thing to remember here is the soft rock erodes quicker than the hard rock. Now, I always suggest, rather than using the word erosion, which is good, can you be even more specific? So, for instance, you could say soft rock erodes quicker because of hydraulic action or corrosion. Now, what happens at that point then is, as you can see here, this used to be hard rock, soft rock, hard rock, soft rock. The soft rock is eroded, and has created bays. Now, bays often have sand at the base of them because the waves hit the headland and they slow down. And as the waves slow down, all the beach material, in this case sand that they are carrying, they drop because the waves are quite constructive at that point. Now, from there, we can still carry on. Just because we've got headlands that are sticking out in bays, what is the next step that happens? Well, around the headlands, the waves are going to refract. They're going to move around it. So what happens then is erosion is concentrated just to the sides of the headland. So here, 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 and here, because the waves curve around them. So in the headland, you've always got cracks. You know, we can't just assume that rock is just one solid piece. There's going to be loads of weaknesses and cracks. As the waves refract, these cracks will grow into a cave, or be a bit more specific, a sea cave. The erosion will keep happening, the hydraulic action, the corrosion will keep going until the back of the cave might erode through. And at this stage, we've got a feature called an arch. Erosion will keep happening at the bottom here, so that opening will get wider and wider. Weathering, so physical or chemical or biological weathering, will happen at the top. And the arch, this is just another example, gets smaller and smaller until eventually that collapses in as well. Until you're left with the headland still that's retreated a little bit, and then you've got a series of things depending on how long this has been going on. This one's called a stack. Stacks then also get eroded down to smaller stacks, and these are called a stump. So loads of keywords there, but try and remember to start and work chronologically. So you get your hard and your soft rock. The erosion happens at different speeds. The waves then refract around, and then you get your caves, your arches, your stacks, and your stumps. 3.7. Coastal management schemes are effective in protecting the coastline from physical processes. Do you agree? And we've got to use an example to explain our answer. So it's the final question for the coast section. They don't do 9 markers, so they're 6 markers, but very similar structure required. We do need some balance, we do need some evaluation, we do need some specific examples. So I would be writing down here Borth and Innislas, because they're the 2 beaches, that is the sort of stretch of coastline we have looked at that has been managed. I would say at Borth Beach you've got a seawall. Has the seawall been effective? Well, yes. The houses in Borth have not really had any major flooding in the last few years, and coastal erosion has slowed down. They've also got, if you can remember, a load of rocks dumped out into the sea. This is called an artificial reef or an offshore breakwater. Has that been effective? Well, again, the answer is yes. The waves hit these rocks as they're coming into shore. It will slow them down, and then as a result, the waves are not strong enough to go over the beach and damage property actually in Borth. They've also got loads of groins. Now, these groins, if you can remember, look really quite worn out. We didn't quite walk to these, but we did see them in the distance. But they've been there quite a while now. They're starting to rot a bit, but they have trapped lots of beach sediment, which normally would go up to the coastline towards Innislas. And you can talk about, you know, the name of the sea there, it's the Irish Sea. The name of the full coastline would be the Cardigan Bay. You could say, well, yeah, the groins have been excellent. More tourists have been attracted to Borth. Talk about longshore drift and the fact that it is being sort of stopped. But then you could also say, well, actually, at Innislas, the sand dunes over time, we assume, will reduce in size. They'll get smaller because all of the sand that normally goes up to Innislas is being trapped between the groins at Borth. And if the sand dunes are smaller at Innislas, then that'll be a smaller coastal protection between the sea and the rest of Innislas. Also on the sand dunes, you've got things like they've planted loads of vegetation on the sand dunes, which is great because they are holding the sand dunes in place and keeping them sturdy. You've also got a few of the paths that we walked to and from the car park to the sand dunes and back. And we could say, well, yes, that's been effective because lots of the tourists used the paths. However, we have seen a few things called blowouts. And those blowouts were caused by people going off the path, trampling down on the vegetation and their roots dying. and then the strong wind that often occurs in Innislas has blown a load of the sand away. So as long as you've got some balance, you use your case study for this question, you should do very well. 4.1, using figure 12, give the 4-figure grid reference for a river floodplain. So remember, the floodplain is the area either side of a river that's often flat and will often flood if there is too much water. So we'll look at the figure that we've got, and the answer here is B, 6304. So it's that point there which indicates this grid square here. We can see the river, and then the flat land either side will be the floodplain. 4.2, using the figure again, which of the following statements best describes the features of grid square 6205? So 6205, which is this bit here, I can zoom in, 6205. It's this square here, where we have a south-facing slope. You can tell how steep the land is by these faint sort of reddy-orange lines. These are called contour lines. And you can see they're really close together here. It's really steep at the top, and then it slopes down from 100 meters to 50 meters, and that's going southwards. We've also got a stream, as we can see here, going through some woods, and then we've also got a tributary that joins the stream here. So the answer for 4.2 is C. And then 4.3 suggests one way the upper course of the River Severn may be different from that shown in figure 12, because this would be the lower course of the river. And we know that because we can see some meanders. You only really get those towards the bottom of the river. So in the upper course, how might this picture be different? I guess the main answers will focus on the steepness of the land. You know, you expect higher up in the upper course that there'd be some steep slopes. You'd also expect maybe that the actual river channel itself would be narrower because there's less water nearest the source. You might say that there might be features as well, landforms such as V-shaped valleys or waterfalls. 4.4, using figures 12, which was the map, and 13, this photograph, what is the height of the land in meters at the point marked X? So this takes a little time because you're going to have to find where this is on the map, which isn't too straightforward. But we can see in the foreground you've got the meandering rivers, and then there is a settlement that we are trying to find the height of. So we'll look back onto the other figure. You can see the meanders here, and then we're after the settlement, which is this here. Now, I've said previous that you can often tell the height of the land by the contour lines here, but sometimes instead of being on the contour line, it will give the number in dark black next to sort of buildings. So the actual height of this place X is 49 meters. 4.5, describe one feature of the meander at Y. So basically, this is called either a river beach or a slip-off slope. This is on the inside bend of the meander, and on the inside of the bend, the river is relatively slow compared to the outside. When the river is slow, the key term is it is an area of deposition. Material is dropped or deposited because the river is slowing down. 4.6, explain how river meanders may change over time. So meanders are bends in the river, and they normally happen in the middle and lower course of the river's profile. Now, why the river bends is because in the ground there's hard rock and soft rock, and it'll always try and find the easiest path to take. So if there's hard rock, it will normally bend around it and erode the soft rock. Now, over time, we need to start appreciate a few of the key terms here. On the outside of the bend, represented by these blue arrows, erosion will happen. And again, if you put the word erosion, don't stop there. Give me a specific time, such as hydraulic action or corrosion. So we are going to get features on the edge of very steep banks. These are called river cliffs. On the inside of the bend, the opposite is going to happen. The river's going to be relatively slow. So we're going to have deposition occurring on the inside of the bends. That's where material like silt is going to be dropped. Over time, this part of the meander, this is called the neck, is going to get narrower and narrower until eventually the river channel is going to break through. It's going to try and find its fastest route. Then, as we can see from diagram number 2, the outside of the bend has now changed to now this side, and then the inside, here and here, material will be deposited. Over time, this deposition will build up and it'll actually block water from going into this section. So what will happen is, if we just move that a bit, is eventually this shape will be cut off from the main river channel. This is called an oxbow lake, and we can see a photograph of one here. Over time, the water here is going to evaporate out, and that will be reclaimed back into land. So make sure that when you're explaining meanders, you also include your understanding of oxbow lakes. Make sure you make it clear about the changes over time. Final question 4.7. Differences in the shape of flood hydrographs are caused by both human and physical factors. Do you agree? So we've got to use some of the figures from these two hydrographs and your own understanding, which is the Boscastle River flood. So what I'd like to do for 6 marks, first of all, let's have a look at this hydrograph here. The bars represent in both of them the rainfall. So there's obviously a big storm. They started measuring from 0 hours. The storm went on for 4 hours. The line represents how full the rivers were. So this is called the discharge, the volume of water in the rivers. Because obviously, as soon as it rains, the river isn't going to fill up straight away. It's not just going to be raining in the actual river. So this is basically what these graphs show us. So in the first one, what would be great to work out is something called the lag time, L-A-G, lag time. And this is the time it takes from when it rained the most, this point here, to when the river was its fullest. So it looks like we've got around about, that was about 2 hours, that was about 8 hours. So the lag time is roughly 6 hours. So why is that? Well, it is due to physical reasons. For instance, rainfall. It's not really going to flood if it doesn't rain a lot. Also, there could have been some snow melt. There could have been steep slopes. There could have been impermeable surfaces. Impermeable rock, just like the natural geology of the area. So there's loads of different physical factors. However, human factors are also going to influence it. Because if you look at Clapham Beck, it's the same amount of rainfall, but the river does not fill up as much. In actual fact, the lag time, looking here, is around about 18 hours. So why is that then? Because the physical factor, the rainfall is the same. So it suggests that at Clapham Beck, there was less buildings, less urbanisation. Because without buildings and roads and things like that, you don't have those impermeable surfaces like concrete and tarmac. If we do have those surfaces, the key word would be surface runoff. The water stays on the surface and runs into the rivers really quickly. So I would suggest that Clapham Beck, less of those, and maybe more fields, where the water can infiltrate, and that would be the key term, goes into the soil, where it could be stored, rather than going into the rivers. Also, maybe at Clapham Beck there are more trees to intercept the water. Maybe at Oswick Beck there is more deforestation, which means the water ran into the river a lot quicker. But again, we've got to use a little bit of our own understanding as well. So try and link this one to Boscastle and say, well, all the things that happened at Boscastle, the steep slopes, the high drainage density, the fact that there were loads of rivers in a small area, would contribute to a flood, which are both human and physical factors. So a lot to do there, but as a minimum, use the figures, try and work out the lag times, and suggest that both human and physical factors can change the shape of the hydrographs.